Welcome to Wildcat Science with Mrs. Haugo. This is Chapter 7, Part 5, the appendicular skeleton. We are going to be studying all of the yellow bones. We're going to start out with the pectoral girdle, which is the shoulder, and it includes the scapula and the clavicle. The job of the pectoral girdle is to support the upper extremities, your arms. Starting out with the clavicle, it is commonly known as the collarbone. It is slender, rod-like bone. It is S-shaped, and it runs laterally between the sternum and the shoulders. It articulates with the sternum anteriorly and the scapula not posteriorly, but laterally, It holds the shoulder in place and provides attachment for muscles. A fun fact is that this is the most frequently broken bone. So looking at our skeleton, this is the clavicle, and it attaches anteriorly with the sternum and laterally with the scapula. Continuing on with the pectoral girdle, let's talk about the scapula. It is commonly known as the shoulder blade, and it is a broad triangular bone on the upper back. It articulates with the clavicle, which is the highest point of the shoulder, and you can feel that on your own shoulder. And it also articulates with the humerus in a ball and socket joint. The scapula provides attachment for muscles that move the arms, chest, and neck. Looking at our skeleton, we can see the scapula is a large triangular bone, and it articulates with the clavicle up here at the top, and also down here it articulates with the head of the humerus. So looking a little more carefully at some pictures, we can see the clavicle and the scapula. Looking a little more closely at this picture, we see the clavicle articulates with the sternum and then also with the scapula at a process of the scapula, and we see there's a depression in the scapula that articulates with the ball, with the head of the humerus. So looking at some more pictures more carefully of the scapula, we can see that there is a fossa or a depression, a supraspinous fossa and an infraspinous fossa. We can see there is a spine. We talked about spines before. There's this process that articulates with the scapula. And then there's another one, which we'll talk about when we talk about the muscular system. And then over here on the lateral view, we have the glenoid cavity, and that is the socket in the ball and socket joint. And then there are a couple more processes. This is the lateral or outside border of your scapula, which you might be able to feel, and then this is the medial or inside border of your scapula, which you also may be able to feel. Here's another picture of the scapula. It is the anterior picture, so if you could see through your ribs, this is what you would see. Again, we see our two processes. We see the superior border, the glenoid cavity, which is that socket joint, the lateral outside border, and the medial inside border. So let's continue on with the upper extremities. Okay, now that's easier for you to read the notes. The bones of the upper extremities form the framework of the upper limbs. They provide attachments for muscles and function as levers for movement. Starting out with the humerus, it is the long bone of the upper arm. And looking at our skeleton, we can see it right here. The head of the humerus articulates with the cavity of the scapula, as we talked about previously. There are several projections or little bumps for muscle, specifically tendon, and also for ligament attachment, which we'll see on the next slide. Looking at the distal end of the humerus, there are epicondyles on each side for tendon attachment, and then the trochlea, olecranon fossa, and coronoid fossa articulate with the ulna. And we're going to see all of these things. It's this one. this one in back here is the ulna. And we're going to see all those parts in the next picture. Okay, looking at some pictures of the humerus, the posterior view and the anterior view, we can see the head of the humerus, and then the neck, which is the slender part, both the anatomical and surgical neck. And then there are some bumps, tubercles. There's the greater tubercle and the lesser tubercle, and these are places for muscle, for tendon and ligament attachment. The intertubercular groove, that would be a place where nerves and blood vessels can go. The deltoid tuberosity, which is a projection for the muscle deltoid to attach. And then down here we have some more projections and depressions. The coronoid fossa is a depression for the ulna to articulate with the humerus. And then we have the capitulum and the trochlea, which are also for the radius and the ulna to articulate with, both the anterior view and the posterior view. And then we have the epicondyles, the lateral on the outside and the medial on the inside, and those are places for tendon and ligament attachment. On the posterior, we also have a depression, but this is the olecranon fossa. So let's take a look at the elbow region. We have the humerus, the ulna, and the radius. And you can see there is the medial, and then there would be a lateral epicondyle also. And up here is the coronoid fossa, which when you bend your elbow, this allows the coronoid process of the ulna to fit in that little notch and for you to bend your elbow. We have the trochlea and the capitulum, which also allows a surface for the radius and ulna to articulate. You can see the radius and ulna are articulating with each other. There are tuberosities, there are little projections, which allow the attachment of tendons and ligaments on those also. So looking at our skeleton, you can see the humerus and the ulna, and that the coronoid fossa allows, when you bend your elbow, the coronoid process of the ulna to fit into that hole. And this happens when you bend your elbow. Now we're looking at the same elbow joint, but from the posterior, from the back. So here's the humerus, the ulna, and the radius, and you can see the opposite thing is happening where the olecranon process of the ulna is fitting into the olecranon fossa of the humerus. But this happens when you straighten your arm. So when you straighten your arm, the bump on the ulna goes into the depression on the humerus. Looking at our skeleton, a lateral view of this, of the back, you can see when it is bent that the olecranon process on the ulna is not in the hole, and then when you straighten it, that projection on the ulna goes into that little indentation on the humerus. And you'll have a chance to look at that more closely during class time. Okay, so we're moving down distally the arm to the ulna, and the ulna is on the medial side above the pinky finger. And so let's look at the skeleton. It's on the medial side above the pinky finger, and the proximal end articulates with the humerus and with the radius, whereas the distal end we'll talk about articulates with the radius and the carpus. With an extended arm, the olecranon process of the ulna, this would be in the back, fits into the olecranon fossa of the humerus. And then with a bent arm, the coronoid process of the ulna fits into the coronoid fossa of the humerus. And so then, as I said before, the distal end articulates with the radius and then also with the carpals. Excellent. The other bone in the lower arm is the radius. and the radius is on the lateral side above the thumb. And we know this because thumbs up is rad. The proximal end articulates with the humerus and the ulna. Looking at our skeleton, we have our radius on the thumb side with the proximal end articulating with the humerus and ulna, and the distal end articulates with the ulna and the carpals. So the distal end articulates with the ulna and the carpals. In anatomical position, which is like this, the radius and ulna are parallel and the ulna is on the medial side. So you can see the bones are parallel and that the radius is on the lateral side and the ulna is on the medial side, all the way up and down. When you flip your palms down, the distal end of the radius rotates around the ulna and the bones cross. So the proximal end, it still stays radius lateral, ulna medial, and then as you rotate the bones, you put your palm down, these bones cross, and now the radius is on the medial side and the distal end of the ulna is on the lateral side. So we'll look again how the top part stays the same, but the distal end, the bottom part, crosses. And that is a good example of a pivot joint, and it allows this freedom of movement. So a little bit more fun fact. So looking at the pinky side, so the ulna, this bump right here, that is the styloid process of the ulna. And there are some very nice pictures on page 144 to illustrate these ideas. Okay, so let's look at some more pictures of how the radius and ulna go together. So we have the ulna, and we have the olecranon process, which goes into the olecranon fossa of the humerus on the back side. Then we have the trochlear notch, which articulates with the trochlea of the humerus. And then the coronoid process, which articulates with the coronoid fossa on this front side when you bend your arm. And then the head of the radius articulates with the ulna. You've got a little bump for muscles to attach. And then the styloid process, again, we talked about well, there's a little bump on the radius side, and then the styloid process of the ulna would be this big bump here. And looking at some more pictures, we have our olecranon process, trochlear notch, coronoid process, the radial notch, where the radius, the head of the radius is, and then this is the proximal end by your humerus, and it's a lateral view looking in. Okay, we're moving distally down the upper extremity to the hand. So looking at the hand, the wrist is actually the radius and the ulna, not the carpals. There are 8 carpal bones in each hand: trapezium, trapezoid, capitate, hamate, scaphoid, lunate, triquetral, and pisiform. We're going to look at a little video to help us remember those. The many individual carpal bones in the wrist increase the wrist's freedom of mobility. There are 5 metacarpals in each hand, starting with the thumb. 1, 2, 3, 4, metacarpal 5. They form the framework of the palm, and the distal end is the knuckles. You also have 14 phalanges in each hand, and each finger has 3, a proximal, middle, and distal phalange, and the thumb has only a proximal and a distal. We're going to pause there, and in our next video, we will finish up looking at the hand and move on to the other types of the appendicular skeleton bones. See you then!